Hello and welcome to CA 121. I'm your course instructor, Heather Hines. Here we're going to be talking about the Chapter 7 vocabulary. Chapter 7 covers 3 really big topics that if you want to become an expert in Excel, you should really play with all 3 of these Excel features to make sure that you are a master in these features. Because if you ever go to an interview where they ask you about Excel, these are kind of the keywords that they're looking for, and they might even ask you to take an exam or a little exam to make sure that you have mastered these. So let's take a look. The first one is payment function. We can create a payment function, so when you go and you apply to create a loan, get a loan for a house or a car, what they're using is a payment function similar to what Excel has. We'll talk about that. What if analysis tools? There are 3 what if analysis tools. That's basically where you have a function, you have variables, and you're either saying, hey, I want you to goal seek, meaning we're going to do a backwards analysis, and we'll show that in a bit. You can create a 2 variable data table, or you can use solver to solve a formula with several variables and constraints. The last one we can do is lookup functions. VLOOKUP and HLOOKUP are very popular. In addition, there's also match and index. So let's kind of dive into this by looking at a sample Excel spreadsheet. Here's your Chapter 7 grader. We're not actually going to solve anything. We're just going to kind of, here we go. All right, so let me delete this because I already know what's working on it. Let's just say we want to know what is my monthly payment if my loan amount is $975,000 for a period of 120 months with an interest rate of 5.2%. So what are we asking? We are asking the question of what is my monthly, key on monthly, loan payment if the loan is stated as above. All right, I want to know how much this is going to cost me. So I am going to insert a payment function. How do you do that? You start with the equal. In Excel, the function is called PMT. And then it'll tell you the 3 things that it needs. It needs rate, which is your interest rate. It needs NPR, which is your number of payments, and present value. Now the key is that I want monthly payment, so all of these variables that I'm inputting have to also be in months. So the rate has to be in months. This is the interest rate per year, it's typically per year, so I'm going to divide that by 12. NPER is the number of payments. They already made it as 120, which is aka 10 years. And the present value is how much is the loan right now. Future value, we don't need to know that right now. And if you were to input future value, so it's an either or, you either do the present value or the future value. Right now we're doing present value because we know the amount of the loan. Right. So it comes out as it's going to cost me $10,460.94. If you don't like that to be a negative number, which in this grader they won't want you to have it as a negative, you just multiply by a negative by putting a negative in front of the payment function, and voila, it turns it positive. So that's how to do the payment function. What if I wanted to reverse that? What if I knew that I could afford, let's just say $8,000 a month? How large of a loan can I get? So you can afford $8,000 a month. How large of a loan can I get? So I might use what's called goal seek and go backwards. So I know my end result needs to be 8,000, so I'm going to reverse engineer that and figure out what would be the amount of the loan. I could also, and I could tell it to change any one of these variables, but let's say, hey, I want to figure out what is the max loan if I keep the other 2 variables the same. So I would go to my data tab, go to what if analysis, go to goal seek. I say, hey, so first thing when you're using goal seek is you have to have something that's related to your variables. So this cell right here, I clicked it because it has a function that is related to all my variables. You see how it's affected by all my variables here. So 2, I want to set it to 8,000. By changing, and this is key, it has to be something that is related to the cell that I clicked as my set cell. So I can change any one of these. I decide to change that one. Press OK. Press OK again. And it says, hey, the max loan that you can have if you can only afford $8,000 a month is $745,631. Okay. I might press backwards to reset it back to the, notice how it overrode it when I did a goal seek. So the max loan that I could get really would be $745,631. Okay. All right. Next, we're going to talk about the 2 variable data table. Right. In order to do a 2 variable data table, you would have variables going across and down. So if this is saying, hey, I want to know the loan if my number of payments was 60 at 7.5%, what if it was 60 and 7%, so on and so forth. So I need an equation here in the upper left-hand corner that relates those variables. So I'd say equals payment, and I'm going to put a negative so it'll turn out positive. Again, my rate needs to be in months, so I divide by 12, the number of months, and my present value. I'm going to highlight everything, including the equation. That's a must. I'm going to go to what if analysis, data table, and I'm going to say my row input is my periods, and so these are the variables that I'm changing. I'm going to press OK, and it's going to tell me my monthly payments. Now, sometimes I always confuse which one should go in my row and which one should be in my column input. So in order to check it, you know that at 120 months at 5.25% interest rate, your loan should be about $10,000 a month for your payments. So I would go here to 120 and down to about 5.25. These should be around 10,000. If not, then you flip to your variables and you just need to flip them back. Okay, so they are correct. So there we go. All right, and the last one is solver. Solver can be used to solve formulas with several variables. So this is a formula right here, and it is connected to 3 variables. Really, I would use solver if it was connected to really complex variables. I wouldn't really use solver for this scenario right here, but we could use it. So I could say, what if I can afford $8,000 a month, and I want a nice house, so the loan must be at least $500,000. I know that my periods, I don't want to be paying more than 30 years, max of 30 years, or how many is that in period? So that's 360 payments. And let's just say I know my interest rate. I can't get a better interest rate with my credit, so I know my interest rate is going to be equal to 5.25% no matter what. Okay? So if we wanted to solve this equation with all of these variables and constraints, then I can go to data. Solver is an add-in that you have to add in separately. I say, hey, what's my objective? Well, your objective has to be related to one of your variables or your equations. So I would say, hey, my objective is to minimize that. Or let's just say that it could be $8,000 a month. 1, 2, 3. By changing what? Here are my variables. And then I can add different constraints. I could say, hey, I know that this number needs to be greater than or equal to 500,000. I want to get a nice house. I'm going to add another constraint. I know that my loan must be, I know that the periods must be max of 360 payments. So I want that to be greater than, or sorry, less than or equal to 360. And I know my interest rate has to be locked in to 5.25%. I'm going to press OK. Look at all my constraints. I'm going to say solve, and it's going to solve it right there for me. I could either restore or keep the software solution, and I could also save the scenario, which is really nice. So I could say, okay, so if I can afford $8,000 a month, I could potentially get the loan of $975,000, but I would have to be paying longer than the 10 years. I'd have to be paying 174 payments approximately. I'm going to press cancel so that it will return back to the original values. So we just talked about payment functions and what if analysis tools. Let's go ahead and talk a little bit about data validation and lookup functions. Data validation just basically says, hey, I don't want any typos. So if somebody inputs the wrong job code, I can make it locked in to where it won't give the wrong job code. So I might say, hey, I want these values to only have the job codes from the job information worksheet. So I would highlight the ones I want to validate. Go to the data tab, go to data validation. I'd say, hey, I want it to be from a list. I don't want it between, and it won't let me change it to equal, so maybe I'll change it to one of these to kind of trick it, equal to, change it back to list. My source, I'm going to go find the list and highlight it, so I want it to be one of these job codes from the job information worksheet. I'm going to press OK, and now in here, when I do this, I can only use things from the drop-down list. So for example, I couldn't just put a random word here. It'd say, no, you can't do that. It has to be something from the list, like MG. Okay, so that is data validation. Lookup functions are awesome because I could say, hey, I want you to read this job code and give me the description and the salary and other things from this job information. So from this job list, I could say, hey, read the job code, give me back the description, or read the job code and give me back the salary. So I do, this is would be called a VLOOKUP because my data is in vertical columns, right? Job code, description, and salary. These are vertical columns, so it would be a VLOOKUP. If this was kind of rotated on its side 90 degrees, it would be an HLOOKUP. Right, so I might say, hey, look equals VLOOKUP. I want you to look up. Then I'm going to say, look up what value? This job code value right there. And I want you to look at this table here. Comma. Column index. Well, I want you to do, if I'm going to be using this formula in multiple areas, I might make that an absolute reference. Column index, I'm looking to see what column that was in, and that was in column 2, so the description is in column 1, 2, the salary is in column 3, so I'd say, hey, column index would be 3, oops, because I went to that worksheet, I did something weird, so I'm going to put in 2, and range lookup, that's, do I want an approximate match or an exact match? An approximate match might say, hey, as soon as I see M, I'm going to put manager. But there's two things that start with M, like assistant manager. So I want this to be an exact match. And generally, you want it to be an exact match. Okay, so I'm going to say true. Press enter. And it should say, look up the job code and give me the correct description. So let's just double check. Is SSTR, stockroom assistant? Yes. All right, let's talk about match and index. We can sometimes use those instead of lookup functions. I personally prefer lookup functions, but we can also use match and index. Match is kind of a tricky one to use because it matches either the row or the column depending on what range of cells you have determined. So I might say, hey, I want you to look for cashier in this list and tell me where is it located. So match will tell me where is it located. So I might say, hey, equals match. I want to look up the value of cashier. It's a word, so I'm going to put in quotation marks. I'm going to say lookup array. I can't just use the whole thing. When I'm doing a lookup array, it either has to be the column or the row that cashier is in, but not both. So I might just say, hey, I want you to look up in this row. And when it gives me the answer, it's going to be its column position. And I'm going to say less than, exact match, or greater than. Less than and greater than are used really for when you have numerical values like salary. Those are numerical values, but I don't want a numerical value. So I'm going to say exact match. I want you to look up cashier exactly, and it's going to say 4. Now, why did it say 4? It's because I highlighted starting here, so it's going to say this is 1, 2, 3, 4th position. So this is its column. To do row, I could do a match. I would say equals match, and then I could again look up cashier. And this time I highlight my row. Notice how I'm either doing row or column for match, but not both. And match type is again an exact match. So then it's saying 2. So it is in the 4th column. This column position is 4. So 1, 2, 3, 4 down, and 2 over. Actually, this is reverse. Okay. Now, why might I need that? Well, I could use that for an index. I could say equals index, and I could say, hey, index goes the reverse of match. It could say find the value based upon its location. So I might say, hey, here's my array, and my row number is right here, 4, and my column number is 2, and it should come up with cashier. So that is how to use match and index. They're opposites of each other, and how to use lookup functions. Hopefully this video was helpful in understanding the vocabulary for the chapter. If you need help with your Chapter 7 grader, please see the Chapter 7 grader video. Have a good day.